Matt, can you, I just hit start recording. It's just telling me, okay, never mind. It's recording.
Okay.
Just when you start, can you just let everyone know that we're recording? I think everyone gets a notice at the top of their screen anyway.
Okay. Yeah, let me know when you want me to start.
Your
Whenever you
video's not on, Matt.
Oh, my video's not on. All right. There we go. But I'm going to share my screen anyway. So I didn't think you really needed to see my ugly mug.
Well, we do. We need to. We need to, so we appreciate how beautiful we are.
I was just going to say it makes everybody else feel better about themselves. It's a self-esteem boost. Okay. Well, I'll get started since it's a Friday afternoon, and it was somewhat intentional for me to book it on a Friday afternoon to force me to keep it short and sweet. And I don't want to take too much of your time, but so I was asked to talk about our Amberg rail system that we purchased in, I guess, late last year in the fall, and we had delivery of it in December. But up until that point, we were using it using a demo version on some projects. I wanted to keep this presentation somewhat as kind of a general overview as to what it is and what it can do. We've used it on some projects, on some small projects. So I think we're still learning with it, how to use it, and dealing with some issues as they come up. But I think it would be just a good idea to kind of get everyone acquainted with rail, what it is, what this thing can do. So the picture that you're looking at here is basically the unit. It's a rail trolley that's lifted onto the rails and that moves along the rails. The Amberg system measures the rail geometry, and that's basically what it does. It's a tool to measure the geometry of the rail. It's a very high precision. Depending on the rail application, you're going to need that high precision versus other applications. So just to give you a general introduction about some rail terminology, basically what you're looking, rail geometry parameters, you're talking about gauge. Gauge is basically the distance between the rails. You can think about it that way. Your cant super elevations, so similar to a road, when you're in a corner, the rail will be super elevated. One rail will be higher than the other. And purpose for this is so you can run at speeds through there without everybody getting thrown off of the rail. Stationing, this is very basic, our typical chainage. So not really any different than a road application. Twist, that would be one rail being higher than the other. So as the train's going on, moving along the rail, you're going to want to ensure that your rail elevations don't induce a weird sort of twist. Curvature, this would be coming into your curves and coming out of your curves and your actual curve. So when you're moving into a curve, you're going to have a spiral and a spiral coming out of your curve. And then you will have a constant radius while you're in the curve. And the purpose of that spiral is so your passengers don't throw up as they're moving on the train. Then we've got position and height, and that's going to be your horizontal alignment and your vertical alignment. So you can see here. Here and here. So any deviations from your horizontal, vertical alignment, and all of these have implications on the durability of your rail. If you look at the statistics, geometry is one of the highest reasons as to why derailments happen. So these parameters are important. So typically in the past, you've got all kinds of tools that you would have to measure these. So you got a gauge bar, similar tool to measure your cant super elevation. You got a tool to measure your stationing. You use your calculator to calculate twist, some tools to measure your curvature, position and height. Traditionally, we've done this either GPS, total station, and elevations through transit and level. And of course, adding your control points along the way. But I'm not going to really talk about that much. I want to kind of more or less stick to the geometry. So you've got all these different ways, all these different tools to measure all of these things to a certain degree of precision. So what the Amberg does is it's one tool that measures everything. So all of those parameters, gauge, super elevation, stationing, twist, curvature, position, height, you're going to measure with this. So it's a modular system. There's a lot of different things you can get for it. Oh, why is that happening? Sorry. So what we've got the basic system, the GRP 1000, and that includes, I don't know why it's changing slides on me. In any case, so we've got the prism. Oh Lord, I'm just going to stop it. Okay, so we've got a prism, our computer, and GPS. So that's the most basic system. So the base system here has got a cant sensor, and here, this length here is for measuring the gauge. So this is a fixed item for measuring your gauge. So gauge is typically in Canada, North America, 1.35 meters. So this is what it's calibrated to. You could change this out for different gauges, but we have it for the single most popular gauge in this country. So we've got a gauge sensor, cant sensor, and then the horizontal positioning and the vertical positioning is done by traditional surveying means, either by total station using this prism or by GPS. You can also have additional IMUs on the system to do that, to track your position as well. Those are additional modules. And then you can attach a big laser scanner on it as well. One thing to note is that you can't put the Leica scan station laser scanners on this. So it's only compatible with a Z&F scanner. So that's something that we can't do with it. So typically railway surveying, there's a few different applications, one being slab track. Slab track is going to be your embedded rail. You're going to have a concrete base with a rail on top of it, and the position of the rail will be adjusted by the adjustment mechanism there. Ballast track is something that all of us know and see every day. It's basically just going to be a mound of ballast with your ties on it and your rails on it. So installing these rails, ballast, slab track, as building, ballast, slab track, those are the applications. So additionally, on top of that, you can do typical mapping surveys that could be done with the Amberg as well, and clearance surveys too. So there is a profiling option on that you can put on it. Not that you really need it. I think you do that by other means, but I think the real effort for this is to use the slab track, to use it for slab track installation, final ballast track setting, and as-builts. So let's see if I can put this back on. All right. So when you're building your as-built of your track survey, typically you're going to want a comprehensive set of track data. You're going to have 3D track coordinates, railhead center line, dimensions of track parameters like curvature, radius, and the Amberg has about 80 different options which you can do in there to measure that track geometry. So you can measure its position, height, curvature, gauge, super elevation, and on top of that, you could customize it to your client as well. You could have it measure the versines, a versine being your deviation from design. So you can set that up to show that in your reporting. So for typical survey, you're going to have a control network. Typically, you're going to set that up along the track. And for the most precise way of doing this, you would set up your total station on one of those points and then measure to the prism on the Amberg. So in this positioning mode, typically you can do about 600 to 1,000 meters an hour. I'd say it requires at least 2 surveys and 2 surveyors to do this. And one of those is going to be specifically trained on that Amberg. I'd say the limiting speed factor in this is going to be your ability to move that total station and then do your next setup. Because as you move from setup to setup, you're going to have to do a certain amount of overlap between setups so that everything blends together. So here's just some images of in an operation. There's Jeff on the track. So basically you've got your total station set up on a control point, and you, in this scenario, you're measuring it as stop and go. But also you've got, and you can see we've got a 360 prism on this. So you could measure this in a continuous mode as well. So I'd say the stop and go is going to be your most precise way of measuring the track positions at each interval. And depending on how you want to set that interval, 10 to 50 meters might work well for that. Or depending on what you're trying to do, you'll have to make that decision on your interval if you're measuring stop and go. But basically, as you go along, you take a measurement, move to the next point, take a measurement, move to the next point, take a measurement. So you can do this continually with the 360 prism, stop and go, or you can attach a GPS to it. So in this image here, we've got our GPS range pole attached to it, and we have this set up with RTK. So in this, we're taking a continual measurement. So as we're moving along the track, it's taking continual measurements and calculating that horizontal and vertical alignment. Remember though that this RTK positioning and the total station position is just giving you your horizontal and vertical alignments. The onboard sensors are still measuring the gauge precisely, the cant precisely, super elevation. That's all being measured by the sensors on board of the unit. So when we talk about different precisions on this, and by the different methods, it's really end up going to be, an issue with the horizontal and vertical alignments and putting this into some real world coordinates. So we've got Amberg tamping, which is the ability to do the, the ballasted track. So that what is the module in the Amberg world, it's called tamping. So when you're I guess when you're building the ballasted track, as you get to the final track alignment, that's when I think you're going to want to use the Amberg. And depending on who you're working with or what you're working with, you can run that Amberg in front of the tamping machine and then have the results go directly into the tamping computer. So you could create this tamping file after 10 minutes and get that into the tamping computer on board of the tamping machine, and they can go about their way. I know we say here guaranteed millimeter accuracy. Of course, we can measure to millimeters, but that tamping machine won't be able to place that track to those millimeters. But I think there's still applications here for the final placement of those tracks, and I think you could do it quicker as well. At least get the information to the tamping machine quicker than we would do otherwise. So they know what they know what to do for those tracks. All right. So as you're doing this, as you're moving along here and making your measurements, typically you're going to have, all right. Sorry about this. Typically, you're going to have a design alignment for that track before you go out. So you've got that design alignment uploaded into the Amberg software, and then as you're going along, it's going to give you your deviations. It'll give you your left deviation, right wheel deviation, all the information you need to communicate to the contractor who's putting this rail in immediately. So all the calculations are there. Instead of making a measurement, going back, making a calculation, then coming back and telling them, all right, you need to move it this much this way, move it this much that way. You have all this information in real time, which greatly increases the productivity. Here's just an image of your Bark 4 tamping machine. Typically, it's hard to see though, but the tamping machine is going to grab that rail and lift it and move it and shake it to get it into the right position. Slab track. So the slab track is kind of your high precision rail. This will be your light rail applications, where you want maximum smoothness, so the passenger can't feel any kind of bumps and movements as they're moving along in their in their track. So you want that as smooth as possible, and to achieve that, you're going to have the highest precision in those rail locations. So typically, you're looking in the millimeter level in these applications. Your performance is going to be a little less than this because you're taking a little more time making these measurements. But in the same way, like you're getting these measurements real time and communicating these measurements to your construction contractor so they can adjust that rail quickly and hit those specifications quickly and without having to go back 4, 5, 6 times. So, and we've used this on some of these applications, and I'm sure we've had some pretty good success on them. So again, with the same thing with the ballasted as with the slab track, you know, you're adjusting the rail geometry. So height of rail heads, super elevation, gauge, that sort of thing. But you're doing it in such a way that that is presented in such a way that suits the needs of construction for those slab tracks. Like if you're as building these things, I would say it doesn't really matter. You just go out there and you survey it. So, but the slab track and the ballasted software programs certainly designed for the construction in those situations. So you can see here a couple images of the Amberg trolley system in the slab track situation. So you can see that it rolls over the connection points, so you can make those measurements and they can quickly make those adjustments as you're moving. Greatly improves the productivity and the accuracy of doing it. So here's a table here which gives you an idea on productivity and accuracies. So we've got the GRP 1000. So really we'd be looking at plus or minus a couple millimeters in those scenarios, and then we can typically hit for 600 meters per hour in a stop and go situation. We certainly can do more in a continuous measurement situation, but those accuracies are going to drop. We'd be probably looking at 3 to 4 or 4 to 5 millimeters in those situations realistically. So as a comparison to if you were to have an IMU on board and running continuously, you know, you're going from 600 meters per hour all the way up to 2,500, which is quite a bit of productivity. And that's when we were out last week playing around this on a track, and I think we spent most of the day doing the stop and go stuff and 30 minutes doing the RTK stuff. So there's quite a bit of difference in productivity. A little bit about project preparation. So generally, we're gonna get some information from our client that's going to have what the geometry of the tracks are. So we're going to have to take that information, calculate it, put it into a file, and load that into the Amberg software, and then go out there and survey it, and then it's going to give you real-time deviations. However, you could end up in situations where you just don't have that information. Someone might ask you to come out as build their track. You don't have any project data, so really, what do you do? What you do is you go out there and you measure it, you survey the track, and then you bring it into either Civil 3D or another rail specific software, and then you do that regression and that smoothing, and then you create alignment from that as-built data. You create an optimized alignment. Then you could take that optimized alignment and feed it back in for if they're going to do any tamping work on it. So you kind of get that direct feedback loop to that tamping machine. So I think that is an opportunity for us, is to look at becoming a little bit of a full feature supplier, not just coming out and surveying the data, but if we can go out there, survey it, come back with an optimized track design, and then give that to our clients. I think there's some value in that. So typically what you're going to see, there's a lot of different ways we can do with this. And this is something that we're still playing around with the reporting of it. So typically what you're going to see is you're going to have deviations from your tracks parameters. So all these deviations are going to be presented in this, I like to call it a change time series. So what you'll see is plus or minus millimeters along some mean value as you're going along. And that way gives you a means of identifying locations of that are outside of what your acceptance criteria would be. So like you, as I said earlier, you've got more than 80 track parameters that you can play with: gauge, cross level, twist, curvature, verse signs, all of this stuff. So you can play with all this stuff. And this is something that we're playing around with now and trying to dig into a little more and see how we could come up with custom reports to make this visually pleasing and make it easy for some of our potential clients to see value in that, creating lift and slew lists and kind of making it a little more, I guess, survey friendly, where we're doing it with, map based instead of less about charts and graphs. So trying to combine them both into something meaningful. So, but there's a lot of customization in here, so you can play around with this a lot. So pretty cool. So really, our Amberg non-motorized, it's a manually operated tool. It weighs less than 23 kilos, and really a single person can lift it, but two is better. It's electrically isolated from front wheel and back, so it doesn't shunt the tracks, and it's built with a dead man's brake. So there's a brake on the handle. Once you let go, the brake is on. So you have to keep the handle down while you're moving it. So for us as a surveyor, faster surveying, error-free readings. There's manpower savings with doing it traditionally. And then you've got the tamping data interface and the real-time correction results. So I think a lot of the projects that we get involved in, this is very helpful. So, and thinking about it on the client side as well, there's benefits to our client as well and the construction company. So that is about all I had prepared for you guys. So if anybody's got any questions, I can do my best to answer them.
Hey, Matt, I've got a question.
Sure.
I noticed in the drawing, or the photo, I haven't seen it in action, but the wheels on the unit, those wheels, like determining the position and whatnot of the track, the smoothness of those wheels, does it matter? Like, I mean, obviously the machine can't be bumped around and damaged, of course, but
Yeah, the wheels are important. So like you can't have a bunch of mud buildup on them as you're going over the rail, because that's going to affect your measurement. They're some kind of polymer compound, and they're replaceable. But I think it's important to do your best to keep those in good shape so they last as long as they can, because I think damaging those wheels is going to affect your measurements.
okay, yeah, no.
I think they have to go for recalibration, Matt, every 200 miles or something. You have to go for
Yes.
calibration.
Yeah, and there's a calibration schedule for this thing that the whole thing will get set down to Atlanta, and they'll do the full calibration on it again. So I think there's a certain lifespan for those wheels as well, because the more you use it, the more they're going to wear, and then you're going to get to that point where you're outside of the tolerance of the piece of equipment, then you'll have to replace it.
Yeah, that makes sense. Thanks.
Hey, Matt, in the beginning, you went over some of those definitions: super elevation, cant, gauge, et cetera, and you referred to those drawings. Is it possible to get like a description of those different things? I think that would be helpful.
Yeah, I can dig that up. A lot of those images, I was freely taking them from Google, so I can put together a little document that has those pictures and a little description. for
Yeah,
them.
it's just helpful if you're talking to clients that,
Yep.
you know their lingo, right?
Yes. And that's something too we're learning as well every time we talk to a client.
Thanks, Matt.
Yeah, rail people have their own definition. We refer, surveyors have a definition or something. You talk to a rail guy for the same thing, they'll have another word for it. So trying to learn those rail
Yeah.
lingo.
Yeah, and, we come from a surveying mindset where we go out and we as-build something, we give somebody a coordinate and deltas. Maybe, there's a little bit a different mindset with the rail where they care more about like the internal geometry of that rail. Sometimes less so much about where it is in the world, but how the geometry relates to it itself.
Matt, do we know who else in the region has one of these? Are these, pretty rare?
I don't believe anybody else has an Amberg. There's competitors that have the Trimble version, the Guido, and everything that we've been told, the Amberg is better and it's higher precision. The Guido was, from my understanding, the software was built off of roads and road thinking, so it doesn't deal with the spirals as well as the Amberg does. Like the Amberg actually creates a spiral where the Guido will approximate it with line segments. So there is some loss of accuracy in doing it that way that we wouldn't experience with the Amberg. There are people out east that have the Amberg. I think there is a.
And Matt, Nova has one at Joffrey, but it's been parked. They got it. It was too complicated, and they just stopped using it.
Yeah, I know there's some companies in Ontario that use one. I think Ryan at Leica was just telling me there's a company out there and they want to know the rate of change of gauge along the alignment. So that is a parameter that they're interested on there. Not only do they want to know the gauge, they want to know the rate of change of that gauge, and it has to meet a certain specification for that rail. My guess is probably GO in Ontario.
If you have to send these away to Atlanta for recalibration, that would mean we'd have to have at least 2 of them, right? Or
Well, if we have one and we send it away, we wouldn't be able to use it while it's gone. But I think the calibration would just be something like 2 weeks. It wouldn't be something too long, and I think you just have to plan it. Maybe you do it in the winter time when there's no rail jobs.
thanks.
So Matt, just further on that, clients have no need to do their rail surveys in the wintertime?
When I was talking to the Pembina folk, they had done stuff in November, and it got to the point where they couldn't adjust the track anymore because everything was frozen.
Right.
So there is that situation where it's too cold and everything's frozen and they can't do anything, and they got to wait for everything to thaw before they can get back in there and do some adjustings. They were telling me that it got to they had everybody come in with the tamping machine. Then it got cold and the tamping machine couldn't do anything. And then they had to do it manually with hydraulic jacks. So I think there is a bit of a seasonality thing here with this, that you're going to want to do it before it gets too cold.
So I get it. They can't do any tamping or adjusting of the ballast when everything's frozen. But do clients have a requirement to do as-builts or condition surveys or what have you? Without the remediation involved, at least in the short term?
So when I was talking to the guys at Pembina, I was asking because CN uses their rails, and I was like, so does CN require you guys to give them an as-built report every month? He says no. It's like, we have to maintain our rails, so it would be something they'd be interested in to keep for their own records if they were to be asked. Then they have it. So that rail yard in Edmonton there, that Pet yard, it's still fairly new. Everything's in really great condition, but even this past winter, they went out and did some repairs to the rail. So they got a tamping machine out there onto it, and it's a bit of a process to get all of that done and onto the rail and getting all the existing trains switched over to another track. It's a bit of a big deal. And I was talking to one of the older guys. I was like, well, how do you currently do it? How did you know that you needed to go out there and do this? He's like, oh, I can see it by eye. You can see it. So, but the question comes is somebody who's been doing this for 35 years looks at something and says, oh, we need to adjust that, but do you actually need to adjust it? Here, you can provide something with the hard numbers and say, well, this is what it is. And someone might say, wow, we don't really need to do that then.
Yeah, it's far more analytical versus subjective, right?
Yeah, I think these things go hand in hand with some of these guys. Some of the older guys who are retiring now, I think the younger guys are a little more open to this and who maybe don't quite have that 35 years experience of walking down the rail and seeing it. Like you could see this stuff on a tangent, on a straight well. I don't know how you see it on a curve because I don't think you can. And something like this will come give you that analytical information where you can't see it as well.
I asked the guys the same questions, Matt. I think I told you at ADT, and I said, how do you know when it's time to fix the track? And he said, usually the engine or one of the cars just pops off the track and something's wrong. And that's what he said to me. He was serious. And well, that's how, while we were out there the first time about 5 years ago at ADT.
Yeah, that seems
the
like
the shuttle train popped off the track.
Yeah.
So.
Yeah, I think there's still a fair bit of convincing that needs to happen. I don't think like in some of these places that you need to go out there frequently and do it, but it'd be nice to build up a client base where we can have a bunch of these yards to do every couple of years. Because I think it's helpful, and I think they still need a little bit of convincing. So part of that is the work that we did at Pembina and looking to create some custom reports that we can go out and show them.
So how important is it to have a scanner on this thing?
Oh, I don't know if I would buy one. I don't know. Do we do a lot of tunnel work? I don't even think we do a lot of tunnel work. So it would be, by the time you get that scanner on there, because you're going to need the IMU, you're going to be adding another probably $350,000 of expense on it. I don't know if that, and the type of projects type of rail that we see in Alberta, I don't know. I don't know if that's worth it. Maybe it might.
So how fast, if you had it, I guess I was at a presentation a couple of weeks ago, and Tronis was talking about their scanners, and they get a lot of work from the railway companies on, what is it, the envelope?
Right, yes.
Surveying the envelope that, and they have to do that fairly regularly, as I understand, i.e. annually or something. Okay. But they'd have to cover a lot of territory.
Yeah, so the mobile scanner that they have, because they run that Pegasus, would probably be good enough for that envelope stuff. Yeah. But I guess if you wanted everything, if you wanted all of those internal geometry parameters to that accuracy, then would it make sense to put a scanner on an Amberg and run it down there? Where they would run it on their Pegasus, they get their clearance measurements, and maybe I'm not sure if they're calculating any track parameters.
I don't think they are.
Yeah, so maybe that would be a little bit of a benefit, and to have a scanner on it. I don't think you could do profile measurements with the profiler as well for clearance. I think the profiler is quite a bit cheaper than the scanner. So if there's a bridge or something like that in the area, you could just run to that point and run a profile on it instead of doing a full laser scan.
But best case, you'd still have to walk this thing down the track. So it's not like you can do 30 kilometers a day. You guess only goes as far as you can walk.
Yeah, and I guess with that Pegasus on a vehicle, you could do a lot in a day and collect a lot of data. Yeah. So with with an IMU on it, would be up to the 2,500 per hour. So if you worked a 10-hour day, that'd be 25K. So you'd be getting up there.
Yeah.
But I guess asking a guy to walk 25K, you'd be tired.
Yeah.
I spent a month walking 25 to 40 kilometers a day. I was tired at the end of the day, very tired.
Well, and this is down track, so it's not like a path.
Yeah. So I think you could probably make the argument too, but I don't know. It feels like something like a mobile scanner on a vehicle would be potentially better. Now, like if you had smaller areas, maybe this would make more sense, I think.
Okay, thanks.
Hey Matt, just to go back to that conversation about when they might need this done. Are there any like provincial or federal regulatory requirements? I mean, it's such a hot,
Yeah.
with the rails when there's an incident and environmental damage. I'm just curious if there's anything out there.
There are internal specifications, I would say, like with CN and CP to maintain their rail geometry. Federally, I don't believe there are. And like typically we're talking on those like tolerances of like 3/8 of an inch. So like 8 millimeters, 9 millimeters. So they're not super tight on those ballasted tracks. Like the statistical data that I was looking at, there's a lot of, so let's say somebody will come out and measure this geometry if there's a derailment. And then they'll say, all right, well, you're out. So it's a geometry issue. But I think I'm trying to remember now, because I was talking with this guy. He was trying to explain to me some of the politics and some of those statistics, and how they're probably a little, like they'll call it a geometry issue when it probably wasn't under certain conditions. So I don't believe there's any. I was doing some research on that and I couldn't find anything conclusive. They do have like speed requirements, and if you have an issue, then you have to reduce the speed. But I think most of the specifications are maintained internally on these large rails at CN and CP.
Yeah, that's interesting, because when you look at highways or even pipelines that go interprovincially or go down and cross into the US, for example, there are regulatory rules, I guess you call it, and maybe not with rail.
I can dig into that a little more again. When I was looking at this a couple months ago, nothing was sticking out as me as to say, all right, under this federal act, your alignment needs to be within 3/8 of an inch or 2 inches of design. Mm-hmm. Or your super elevation needs to be this. I always came across like a CN design manual people would refer to. I would think CP might have something similar.
Okay, thanks.
Hey Matt, it's Andre here. I think it's very critical on bridges crossing as well. This is something that they probably must do very often.
Yeah, I think are you thinking more in the construction of the bridge or like monitoring of the bridge?
No, maintenance of bridges.
Okay. Well, yeah, that's a good point. I know like companies like CN and CP will have their sensor cars. So they have sensor cars that measure track geometry as they run over things. So I think that on a lot of these main lines, a lot of this stuff is already done. Doesn't mean that we couldn't do work for them. We could be in areas where they can't be. But I think a lot of that stuff on these big lines and main lines that include those bridges are probably already monitored by CN and CP with their sensor cars. But it's a good point, and it's something that we should bring up and talk about when we talk to them. Well, I guess if nobody has any other questions, then this went a little longer than I thought. I'm glad everyone was interested and had all those questions. Well, I think if keep this tool in mind as projects come up, and know that we have it. Certainly, Andre, you do all the work, most of the work in Edmonton. We don't do much in Calgary, but as it comes up, this is good stuff to keep in mind. Or as stuff comes up in the north too, who knows? Remember that we have things like this that can help you on those projects.
Thanks, Matt.
And I was gonna say, as in other offices, as we're getting used to this thing, we got to come up with a training manual so we can standardize our training and get people using this thing for different offices in different regions. So it's not just one person in one office. And that's something we're working towards as well.
Great. All right. Well, thanks a lot, Matt. Really appreciate it.
Yep. So if anybody's got any other questions, you can email me, call me anytime. I'm happy to talk about it.
Okay.
Thanks, Matt.
Cheers.
Bye.
Thanks, Matt. It was really informative.
All right. Thanks.